Hi guys, it's your boy DF4Gents and welcome to my channel. And if you are new on this channel, please do not forget to like, share and subscribe for more scholarly videos. So today we'll be looking at something very interesting. 2 days ago, someone asked me a question, okay? If it's possible for a father who is blood group A and a mother who is blood group B to give birth to a child who is blood group O. Okay, a father who is blood group A and the mother is blood group B to give birth to a child who is blood group O. Now, that's a different blood group entirely, okay, of the child, different from the father and the mother. Now, is it possible? The answer is yes, it's possible. And in this video, we'll be looking at the possibility of how parents with same or even different blood groups, okay, of maybe A and B, giving birth to a child with a different blood group such as O. Okay, now when we're looking at the blood group system, apart from the ABO blood group, we have other blood groups such as MNS, KL, Duffy, LI, and others. Okay, but we look critically at the ABO blood grouping system due to its clinical significance, okay, in compatibility testing. But that's a topic for another day. Now, in the ABO blood group system, okay, there are four types of blood groups there. Now, you could either be blood group A, or you have blood group B, or you have blood group AB, or you have blood group O. Now, for me to be blood group A, it is either I am an heterozygous A or an homozygous A. Now, for me to be blood group A, now there's what we call blood group phenotype and blood group genotype. Okay, blood group phenotype and blood group genotype. I know the genotype you might have heard or looked at maybe on HB electrophoresis or the normal hemoglobin AS. But in blood group, we also have blood group phenotype and blood group genotype. Now, when you see somebody's blood group A, what you're actually talking about is the blood group phenotype. Okay, but genotypically, the person could either be blood group AA or blood group AO. So if genotypically you are blood group AA, it means that you are what? An homozygous A. And if you are blood group AO, genotypically it means that you are an heterozygous A. For me to be blood group B, it is either I'm an homozygous B or heterozygous B. So I could inherit B from my father and O from my mother. Okay, I will still be blood group B. But I am an heterozygous B. So genotypically, those persons, they have BO, but they are still blood group B. While other persons, they could be blood group BB. They are known as homozygous B. Okay, now for me to be blood group AB, I must have both A and B antigens. I must have both A and B. Okay, now for me to be blood group O, I must be homozygous. There is something like heterozygous O. For me to be blood group O, genotypically, I must be OO. So we are going to look at some cases now, about 3, 4, 5 cases of how it's possible for a man who is blood group A and a wife is blood group B to give birth to a child who is blood group O. Now, let's look at this case. Now, looking at this first case, okay, you see that the father is blood group A and the mother is blood group B. But the father, genotypically, is an heterozygous A, while the mother is also an heterozygous B. Okay, now, if it crosses, you find out that they have the probability of giving birth to a child who is blood group AB, blood group A, blood group B, and blood group O. If you look at it, if you look at that case one, you find out that I actually classify them into genotype and phenotype. Now, phenotypically, you see A, B, and O. Okay, but looking at it genotypically, you find out that the person, if the child is AB, okay, he also inherited, okay, the A and B gene. Okay, now if the child is A, from this case now, the child is going to be an heterozygous A. So genotypically, that child that will be blood group A will be having AO genotypically. Now the child who is B will also be heterozygous B. having BO. Now look at the child who is O, is having OO. Okay? Inherited from the father and the mother. Now let's look at case 2. Now this time the father is also A and B. The father is also A and B. But this time the father is an homozygous A, which means that genotypically is having AA. And genotypically the mother is also BB, which is blood group B. Now, in this case, let us see if it's possible for this parent to have blood group O child. Now, if it crosses, you find out that the only child they can have is children who are blood group AB. You see the difference between case 1 and case 2. The same father who is blood group A, the mother is blood group B. But the first one, the parents were heterozygous A and B. Why this time the parents are homozygous A and B? So in the first case, it was possible for the parents to give birth to a different blood group, which was blood group O. Okay, but in this case, it is not possible. It's not possible. That is why blood grouping can give you an indication if a child belongs, at least if a child belongs to a particular parent or not. But take note that it is not enough for you to tell someone with just blood grouping that this child is yours or this child is not yours, and there are reasons to that. But that will be a topic for another day. There are reasons to that. Okay, so but you could actually know, you could actually have a hint that this child doesn't belong to this man. Okay, so just imagine a father. Okay, let's go to the next case. Now, case 3. This time the father is also A, the mother is B, but this time the father is an homozygous A, while the mother is an heterozygous B. Now, if they cross, they have a probability of giving birth to a child who is blood group AB. They have a probability of giving birth to a child who is blood group A. Okay? You find out that it's only blood group AB and A that they can give birth to. Okay? Now, you find out that both the children who are going to be blood group A are going to be heterozygous A. Okay? So, phenotypically, they are blood group A, but genotypically, they are blood group what? AO, which means that they are heterozygous A. Now, let's look at case 4. Let's look at case 4. Now, a father, this is a different thing entirely. A father who is blood group AB and a mother who is blood group B. Okay, sorry for what I did there. Okay. Yeah. A mother who is blood group B. Okay, so you see that if it actually crosses, this time the father is AB and the mother is heterozygous B. So if it crosses, let's look at the probability of children they can get. They have the probability of giving birth to a child who is blood group AB. They have the probability of giving birth to a child who is blood group A, and they also have the probability of giving birth to a child who is blood group B. Blood group B. But something very interesting happened there. Okay, now if you look at the child who is blood group A, okay, though phenotypically he is blood group A, but genotypically he is an heterozygous A. Okay, now look at one of the child who is blood group B. Okay, phenotypically is blood group B, genotypically is an homozygous B, genotypically. And they also have the probability of giving birth to a child who will be blood group B, but genotypically will be an heterozygous B. Okay, now this is the blood grouping system. All right, so let's say for example now, in this case now, where the father is AB and the mother is B, whether homozygous B or heterozygous B, and they now came to do blood grouping of their child, and we're now seeing that the child is O. That's already a question. There's a question mark there. There's already a question mark there. Okay, but you can't tell them that just with blood grouping that the child is not theirs, or you not start, no, that can land you in jail. Okay, that can land you in jail. Okay, so let's look at case 5. This time the father is blood group AB, the mother is O. So like I said before, for someone to be O, genotypically you are homozygous O. That's OO. Okay, now if they cross, let's look at the probability of children they could give birth to. Okay, they have the probability of giving birth to a child who is blood group A, and they also have the probability of giving birth to a child who is blood group B. And whether they are A or B, you see that genotypically all of them are heterozygous. Okay, all of them are heterozygous. Okay, so hope I've been able to answer the question and prove that it's possible for a man who is blood group A and a woman who is blood group B to give birth to a child who is blood group O. It's very, 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 very possible. Okay, and hope I've been able to communicate that. Okay, so and this blood grouping of a thing, okay, even in professional exams, okay, I have seen past questions like that come out in professional exam for medical laboratory science students, especially first professional exams. Okay, they could bring 5 samples. Okay, let me just say 4 samples. Okay, they will say sample A belongs to the father or Mr. So and so. Sample B belongs to the mother, Mrs. So and so, and sample C and D belongs to let's say Emmanuel and Blessing, who happens to be their 2 children. Prove that this Emmanuel and Blessing, okay, belongs to Mr. So and so. Okay, so you have to now do this thing I just showed you now and trace to actually prove that these children belongs to Mr. So and so. You get? But in real life, in practice, like I said, you cannot use blood grouping, okay, to tell someone that this child belongs to you or this child doesn't belong to you. You can't do that, and there are reasons for that. Actually, there are reasons for that. Okay, maybe that will be said in another video. Okay, so thank you guys for listening, and if you're new on this channel, please do not forget to like, share, and subscribe to this channel for more scholarly videos. Thank you very much.